is the Real AI and Digital Transformation podcast series, empowering technology and business professionals to succeed with AI and digital transformation. Now, here's your host, best-selling author and series editor of the Pearson Digital Enterprise book series, Thomas Earl.
Hi, this is Thomas Earl, and welcome to another episode of the Real AI and Digital Transformation podcast series. Today I have with me Thanos Diacakis, the software engineering effectiveness coach and technical leader at Cosmic Teacups. Welcome, Thanos.
Thanks for having me on, Thomas.
Super. Today we're going to talk about the impact of AI on software engineering and the benefits and risks of vibe coding. Where should we begin, Thanos? What have you seen, and what have the actual benefits and consequences? What have they been in the real world so far?
Yeah, one of the first consequences is I think this is one of the most exciting times in the industry that I've ever been in. And I've been in it for about 30 years, but I don't think we've seen such a dramatic transformation of what happens in software engineering for such a long time. So I think the first consequence is I'm super, super happy and super excited to be working in this incredible time. We have these new powerful tools that get rid of a lot of the drudgery of the work that we used to do before and enable us to focus on sort of higher layer items and deliver much more work and much more features to our clients at a much faster pace and high quality. So whatever the motivation people had to go in, and I enjoyed making things, now I can make a lot more things a lot better, a lot faster. So that's super exciting.
So it's a productivity improvement. It's obviously something that is generating a lot of potential business value, but it also, as with other uses and applications of AI, introduces risks and has limitations. We've heard of them, but in real world development environments, in development teams, what have you seen as the most concerning consequences or the risks that organizations should be most aware of?
Yeah, so let's start with one of the most basic things, which is that AI changes everything and it changes nothing at the same time. And what I mean by that is that if you had a bad software development process and a bad culture in your team, AI is going to accentuate that. It's going to make it, if it was good, it was going to make it better, and if it was bad, it's going to make it worse. So it's not inherently something that's good or bad, but it will highlight what you already have in there. So going into sort of more specifics, like if you had sort of good process of shipping code and getting code out the door and reviewing things and testing things, you're probably going to go faster. But if your process was not really that good, it's going to start biting you in places. So does that make sense at a high level?
It does. By process, do you mean if you were following clear policies and standardized coding practices, and you had a governance framework in place that oversaw the maintenance of what you were developing? If things were carried out in a more formal manner previously, then that will help minimize the risks of AI-assisted coding. But if things were managed in a less structured way, in terms of developers doing things their own way without much supervision or without much need to adhere to standards, then bringing AI-assisted coding into that will only add to the chaos.
Yeah, I think there's a few things that I would tweak a little bit, but I think that's the general gist. I don't think I'd say formal is necessarily the word I would use there. I think you want to have some engineering practices that support what you want engineering to achieve. So one of the things that I've kind of follow a 4-step framework as I develop with different clients, and it starts with iterations. Can I get code out into production fairly quickly and in short cycles so I can start getting feedback on this code. The second step is quality. Do I have the right controls to make sure that what I'm shipping is good and I don't create more errors? Once I have these two going, I'm usually in a pretty good shape. But what usually happens is now you're shipping a lot of stuff and complexity starts to increase. So step number 3 would be to make sure you have processes in place to manage complexity. Are there features that are no longer using? Are you investing in removing technical debt from your code? That sort of stuff. And then finally, when you have all these down, I usually look in long-term predictability and planning and all that sort of stuff. So with some system, maybe you have this system, you have some other system that is designed to achieve your goals, you can actually be in a pretty good place and find out how AI sort of transforms your process and you have to adapt a little bit to deal with it. But if you have none of these things, then it will just accentuate what you had. One of the interesting things is you mentioned sort of vibe coding in the very beginning, right? And I don't know if you've covered this in previous episodes of the podcast, but the original term that was used for vibe coding was meant to be where you're coding with just the vibe. You don't really look at the code, you just go with a vibe, and you never look at what the AI is doing, and you see where that goes. And I would argue that even with today's AIs, which are much better than where they were 6 months ago, if you try to do this for long enough, you're probably going to get into trouble pretty quickly. Like the AIs do need to get pulled back a little bit. They do need a little bit of design injected. They're very quickly improving on that, and they're getting much, much better, but they still need a fair amount of steering to build some scalable and lasting application. So I tend to not use the word vibe coding. I'm happy to say like AI assisted engineering, because that implies there's still engineering tasks that you do. There's all these things that I mentioned before of having some kind of designed process of how you want to get software out the door, and following that, using the AI to accelerate the parts that were the drudgery before, right? Like I don't need to look up, what does this API look like, and what does that API look like, and how does the transformation happen? The AI is pretty good at handling tasks of sort of that scale, and then figuring out how to group these together in AI assisted engineering, not just fully going by the vibe.
How much does prompt engineering play into the success of AI assisted coding? You mentioned that if you just follow the vibe and let AI generate code without much oversight, it can lead to, problems or not achieving what you want it to. It needs a structure, a framework, a design. But do you see a potential for advanced prompt engineering to allow that design to be incorporated in what you request of the AI so that it can do more autonomously in terms of building what you want it to build? Or does it have hard limitations now, regardless of how much of a context you establish with it, how much of a history, how much detail you give it in terms of your prompts, your input to it? Does it have simply hard limitations as to the quality of what it can produce or the scope of what it can produce in terms of just the coding?
Yeah, that's a really good question. I think when we looked at this 2 or 3 years ago, we thought that prompt engineering is going to be a thing where you just have to find the right incantation to make the AI do the right thing. And I think that is not really the case. I think there are certain ways to talk to the different LLMs that work better or worse. And I think everyone should experiment with those and find what they are. And I'll give you a couple of examples with that. But in general, I think there are many good ways that you can ask for something and get the results that you need. So in general, I would say what you need to do is sort of have the structures in the overall methodology that you develop software. That's kind of more important than how you specifically ask for a given feature to be done. In terms of the process overall, like one of the things that I really like is having a really solid CI/CD system. So when you push some code, there is a slew of automatic quality checks of different kinds, from static analysis to different kinds of linting, to unit tests, integration tests, end-to-end tests if you have any. And anytime you create some kind of error in that, and you ship it to production, you can go back and say, could I have caught this error early in the process and build some check. And it's cheaper than ever using these AI tools to write these tools. So like you can have hey, AI, we made this mistake. Last week we shipped this sort of thing. Can you write me a linter that catches this thing in CI/CD? And boom, there you have it. So I think that is where I would focus most of the effort, not sort of in prompt engineering. That said, if you look at the specifics of prompt engineering, to go directly to your question, the AIs are a little bit of sycophants still, right? They're a little bit too eager to please. So if you ask a question in a positive kind of way, you're likely to get the answer that sort of reinforces that. And they're getting a little better with that, but I'm still finding the case that if I kind of nudge it in a given direction, it's very quickly going to just agree with me and go and do it. So oftentimes I'll have to phrase it and say, hey, I'm thinking this, but I'm not sure it's a good idea. So give me 3 more options and write me some pros and cons, and you let me know what you think. So you kind of like prompting it in a way that it can be a bit more objective and do what it's good at, right? Draw from like this wealth of knowledge that it has. It doesn't have limited memory like I do. It doesn't get tired like I do. So it can do a much better job in picking all these things out for my solution and judging it and giving me like a list. So at the end of the day, if it's made a mistake, I can, it can trigger my little spidey senses and go, you know what? Your analysis is good, but I actually kind of like option 2 better. So maybe we roll with that one instead. So that's the sort of things that I would pay attention. And I would encourage everyone, you need to play with these tools. You need to work with them. And if it makes a mistake and it says something stupid, don't just write it off and say, this is stupid. I'm done with it. But figure out, how can I ask this differently? How can I do this in a better way? How can I catch this in a different part of the process? Because learning how to interact with these tools is going to be critical as to how we evolve as engineers.
Right. And communicating what you liked or didn't like, or what worked or didn't work, back to the AI with which you already have a historical context and historical exchanges, will help it better understand your specific goals and requirements, I would assume. In relation to coding, comparing it to how many use generative AI to produce content for publication, for reports or various types of documents, a common approach is to say, here's a report we produced previously. We'd like a new report like this, but with this list of topics or with this end result instead. And it would use what you gave it as an example, as a template, to produce something new based on that, based on writing style, based on scope, based on other types of conventions that you may want it to preserve in what it generates. Does the same approach work with AI assisted coding, whereby you say, well, here is code from an application or a part of an application, a feature set or whatnot, that worked, that was successful, that was correct for us, but now we need to build this other part. We want comparable approach to coding, comparable quality of the output, comparable functionality or user interfaces that it may be producing, that you want to based on whatnot. Does that approach work with AI assisted coding as it works with just regular textual documentation?
Yeah, so let me split this up into 2 kinds of ways: greenfield projects and legacy code bases. One of the things that I'm finding is with greenfield code bases, stuff that is written from scratch using AI, and it's pretty new and it's been kept at a pretty good style and architecture. Most of this stuff you don't really need. You may have needed like 3 or 6 months ago, from right now of June of 2026, but I'm finding that less and less, this is not necessary. The AIs just dig in enough in your code base and can see how you've already done things and produce really consistent results time after time. There's still some times where they keep repeating the same mistake over and over again, and you have to be explicit and say, you know what, could you make sure you write this to your memory or your age or your skills file to make sure you remember this. And it's much better than it was, say, 6 months ago, where you had to constantly remind them of this. It really should work this way or that way. So I think that's not really a problem for new code bases. For existing code bases, I think this is a bit more problematic. And the reason that is happening is because you have, if you have like a 500,000 line code base and there's plenty of really, really bad examples and some good examples, the AI doesn't really know what to copy correctly. It doesn't know why this is good or bad. I mean, it could know what is good or bad, but it just doesn't, in the question that you give it with all the other constraints that it has, that aspect of it doesn't highlight enough for it to produce consistent results. Now, there's two ways you can play this, right? One is you can go write some rules and skills and say, hey, go do this, go do that. In these cases, do this. But one of the things that I've also found that is super powerful and is well worth exploring is you can actually refactor really large code bases and make them look really good over a short period of time using the AI tools. In the before days, I might take 2 or 3 years to do one of these big refactorings over a really large code base. And usually these things carry a massive amount of risk. And it was one of these things you did like a few times in your career. And like most of them probably didn't really go that well. Whereas in the last maybe 3 to 6 months, I've done like a half dozen of these using the AI tools in a very safe way. They all went really well. And we replaced legacy code bases that were rickety and not really well written with much more modern versions of these code bases that perform really well. They work really well and have really good examples from the AI to copy with. So again, this will depend. You can't always take that approach depending on what your other criteria are. But those are, I think, the two tools that I would reach in my toolbox to deal with legacy code bases.
So in how do you see this now translating to the workplace in terms of the downsizing of development teams, the impact on those who have built a career in programming and engineering? What have you seen happen over the past while? Have you seen actual downsizing? Have you seen retraining or repositioning developers into different roles to work alongside AI-assisted code-generating systems? Or have you seen basically an expansion of scope within organizations? Whereas, as you just mentioned, you can now produce much more code in a much shorter period of time. So instead of saying, well, we're going to build another application like we did before, but now we only need 5 developers instead of 10 because we're going to be using AI-assisted coding. Instead of letting the other 5 go, is it more about, well, those other 5, we'll train them on AI-assisted coding, put them on another team, and then in the same time span, build 2 applications instead of 1. You hear different stories about how organizations are approaching this, but what have you seen?
Yeah, so in general, I would say when we figure out how to make something cheaper, we end up wanting more of it, not less of it. So I think our appetite for software is going to go up by a lot now that we can produce it a lot less expensively, or as we figure out how to produce it a lot less expensively, because I don't think we've completely figured it out yet as an industry. So I think there's a lot of layoffs that definitely have happened, or companies have not hired people where they would have been hiring. I think I would probably blame a lot of that to, just being an excuse, right? Some company wanted to lay off a bunch of people to make their numbers better for the next quarter, and they'll use the AI as an excuse. I'm not convinced that the organizations that have the tens of thousands of engineers have fully figured out how to harness AI at that scale, where they can, double the work with half the work size. Now, if you sort of start looking into the future and figuring out what may happen, I think the job of the coder is pretty much dead. Like, no one is going to hire you to actually type in the code anymore. That is not a thing. The job of the engineer is still alive, and I think that's going through massive transformation, and we will see how that evolves over time. My guess is that starts moving up the levels and keeps moving up the levels, right? So before, you might spend a lot of your time actually writing the code. Now you might spend your time sort of organizing features and figuring out what the architecture looks like so features can coexist. And then after that, you might be figuring out how to organize your teams of agents to do this. And then after that, you might be figuring out what are the different quality controls you can put in there to go even faster, because now you have all these agents and they're producing code faster than the organization can consume them. Actually, I have a couple of clients that have this problem where the engineering team and the product development team is producing so much change, good stuff, good features, but the rest of the org cannot absorb them. You're like, okay, you've pushed like so many new things, we just don't have the time to deal with this right now. So that's showing like the creaks and the cracks show up in different parts of the organization outside engineering. So I think all that is going to evolve, all that is going to change. And I think definitely the role of the software engineer is going to change over time. But I'm trying not to be delusional because that is kind of my profession. I think we're going to keep moving up the scales. We're going to have to keep learning. No one's going to teach us these things. Everyone is going to have to experiment. And there's so much change happening right now that the amount of experimentation that one has to do surpasses, at least for me, anything I had to do at any other point in time in my career, where I might spend 5% or 10% of my time experimenting. Now I'm spending half my time experimenting, which is super exciting. So I'm bullish on the path of software. It's going to be super different, but I think it's still going to be there in some form going forward.
So, as you just described, AI is replacing the role of the programmer because it can generate code much faster and much cheaper, and currently relies on human software engineers to oversee what it's doing and give it direction. But is it that software engineers, software architects need to pay close attention to how this plays out over the next few years, next 5-10 years, who knows, in order to stay on top of it in terms of maintaining a level of expertise that ensures that they always have the ability to position and give that direction? Or do you see a possibility of AI advancing to a point where some in organizations say, you know what, the role of the software engineer is really not that necessary either, because these systems, may have systems generate code, we may have other systems generate architecture or technology strategy, or generate that direction instead of a human. Do you see it going in that direction at some point in the foreseeable future?
So I'll give you a funny story relating to this, which is I wrote a dashboard a few weeks ago, maybe even more like a month ago, that had all the open pull requests that my AI or my people for various projects that I work on had generated. And I always sent them back for like 3 specific reasons, one of 3, and then if I didn't, then I approved them and they went somewhere else. So I wrote the dashboard so that I could quickly like see what the problems were and then copy paste a message that would either go back into the ticket system or to the human to say, hey, go fix this before you send it back to me again. And then at some point it occurred to me like, geez, I don't really need to be in this loop because I could just make the dashboard just send the messages to the right places. And then it dawned on me like, okay, if I get out of this loop, then what am I going to do all day? Because I spent my last few days working with that dashboard of just looking through it, copy pasting things around, and just telling people what to do. So I was like, okay, what does my role become? Like, what am I good at? And as I was pondering that question, what am I good at is judgment, right? The AI is trained on the whole internet plus some extra stuff that may or may not be slightly better, but its judgment isn't quite there yet. So I think our job as software engineers over not the next 5 or 10 years, but 5 or 10 weeks, maybe 5 or 10 months, is to figure out how to develop this good judgment and how to apply this good judgment in the software development lifecycle wherever you are right now as it's moving up and up the levels. And that's how you stay relevant, right? Figuring out what you do better than the machines do. But to do that, you need to understand really well what the machines do, stay on top of it, and then keep those experiments going. Mm-hmm. And, are we going to be completely written out of existence? I don't know. It's possible. But we still haven't seen the AIs have that good of a judgment. Now, it may be coming faster than we think. So that's something to keep an eye on. But I think the process is one, is to stay on top of it, keep learning, keep adapting, keep changing. And that's the best we can do.
Well, looking at what has transpired and how, things have evolved from a programming perspective, when this first became accessible, AI-assisted code generation, was there a lack of quality, a lack of judgment in terms of how the code should be structured, how it understood what the what the prompt was asking for, or how the output was matching the expectation. And then now it's been some time, and we're talking about the coding role being superseded, the human coding role being superseded by AI itself. How programmers, I mean, not in terms of being replaced entirely, but how the actual manual coding task is being replaced, and how programmers now need to focus more on oversight, or assembling different types of AI generated code together, or still being involved, but perhaps to a much lesser extent than before. But we've seen an evolution in that, so that we now trust AI to a certain extent to produce relatively good code with oversight. At some point, that code we might just trust it. It might be code generated. It has a history of generating successful application code, or snippets of code, whatever we require. It might have a separate AI system doing quality assurance and so on. We get to a point where we go, yeah, we're 99.9% sure it'll be fine. So why spend any more time having a look at it? And I guess if we are heading in that direction, then that judgment that we now need from software engineers, we know we need to rely on it. But over time, perhaps there will be a greater trust in the engineering part of this as well. Well, the architecture, we're clear about what we gave it. The architecture that it'll produce at a glance looks okay, looks good. Should we spend more time and money reviewing it or analyzing it? Are we even at some point qualified to better analyze it than perhaps another AI system that's been trained to analyze software architecture? And do we reach a point where we can just rely on generative AI to produce complete applications for us? It's impossible to predict, but I'm just interested in your overall sense regarding that.
I think we will probably get there, and we'll probably get there faster than we think. So in my own journey, maybe 6 months ago, I was telling the AI what to do, and it was prompt over prompt. And it was like, you tell it something, you wait for a couple of minutes, you make some changes to a file, you look at it, you correct it a little bit, and repeat that over and over. And over the course of a day, it built a major feature, and you had to stay on top of it. If you just sent it off in sort of agentic mode to do its own thing, it would come back with just junk. It wasn't usable. And then somewhere around the February to March timeframe, you could actually send it to build a medium-sized feature, and it would come back mostly correct. And you'd make like almost no corrections. And then like within the next couple of months, I spent a few weeks reviewing hundreds of PRs of which I could find no fault. Now, there were probably there were definitely known faults, but I couldn't find them as I was looking at them, right? So now the AI is generating it at a quality higher than humans can find with some reasonable discovery procedure in there. So then you get to trust it. And now you're like, okay, well, if this is generating PRs at a faster pace than I can look at them, and I'm beginning to not look at code, well, what would I need to do to sleep better at night that this isn't junk, right? That this passes my 99% test, or pass the equivalent of humans, right? Because it may not be, would my engineering teams always find, including myself, find every bug out there? No, I probably caused the most recent outages. I probably caused them myself. Because while I'm pretty good, I'm not perfect, and I definitely still make mistakes. So then you move up a level and start thinking about, okay, well, what would I need to do? So like one of the examples that I did recently is, hey, I had this new app, and I said, let's go go do a full review of the authentication authorization layer in this app. And it went through and said, okay, well, we have 35 endpoints, and I found 2 that actually don't have this pattern, and we need to add it on. They were not authenticated. And I found 3 more that are using a different pattern, so let's standardize this across the board. And then I suggested that we write a linter, so every time that someone adds an endpoint, that we just go check these 3 things automatically, so it just complies to the pattern. So that's kind of an example of how like my thinking now doesn't have to be, okay, how did you code this particular endpoint? But I put the procedures in place to make sure that it works correctly. Now, I could add like hundreds of tests for everything that I do, but that would become infeasible and uneconomical because now tons of things have to run every time we make some little change. So then you're starting to use your judgment of, okay, well, what are the sort of errors that we're creating? What are the sort of tests that we need to build? And you're now applying your expertise at a different level. And that's kind of what I referred to before as sort of moving up the chain. So I still see us doing that, and that will go higher and higher and higher level. And we don't know exactly what that looks like, but you could sort of see where you maybe ask it to build an app and you still have to give it some judgment of, okay, use this app development methodology or that, because I think this fits better into what we're doing over here. And here's some critical decisions that I want you to make in this way. There's still, I think there's going to be some human involvement because the wishes and desires still have humans in the loop. And again, if you look far enough in the future, maybe that eventually goes away, but we'll cross that bridge, I guess.
Super. So, that's extremely insightful. I guess to conclude, if you could share right now where we stand with regards to utilizing AI-assisted coding in the real world. We talked about the potential and the benefits. We touched upon some of the risks, but what would be the top 3 pitfalls or problem areas or just dangers of bringing AI-assisted coding into your IT department today? And just be as specific as you like. Maybe there are specific things where despite best efforts, it just still can't get there, or whether it's technical or cultural. What would be the top concerns that you would like to share with organizations to look out for?
Yeah, the first one would be not to play, right? Maybe you had some bad experiences, or you think this is a bad idea, or you just don't like AI and you decide not to play in this ecosystem. I think if you do that, you're going to be a loser. There was a point in time where the AI was producing code that I couldn't review fast enough, and I was like, is this irresponsible to deploy this code into production when I actually haven't looked at it? But then it was producing such a accelerated pace that would impact the bottom line of the company, and we could make fixes if we found problems on the way, that we irresponsible not to use it. So we went with using it and then adding some additional controls to make sure it's using well. So my top concern would be, I tried this once, didn't really go well, I'm just giving up. My second concern would be the lack of experimentation. There's just so many things happening right now that you have to keep experimenting, you have to keep trying things, and you have to allocate probably more time than you may feel comfortable with to this experimentation to make sure that you're catching all the most recent changes. Like some teams just get so bogged down to actually doing the work, it's really hard for them to take a step back and say, okay, how are we doing this work? Is this the right tool for the job? What else could I use to figure this thing out? So look around, talk to your peers, look around what's happening in industry, and play with different things to see how it works and how it fits in your org. And the third thing that I would say is, it's not just about AI, right? So if you want to use AI, but your overall process or culture are broken and you have issues in there, seek to fix these at the same time or as you're using the new tooling. Because if you just accelerate something that's broken, you're just going to get more broken. Whereas if you fix it, you have the opportunity of really having that true transformation and figuring out what your bottlenecks are, and then really having an impact at the other end of the business. Because at the end of the day, all the software organizations goal is to ship enough features to customers that the customers trade them off for their cash, and that's sort of the engine of the business. Mm-hmm. So if you're not actually putting out stuff that is valuable to your end users, you kind of spin your wheels.
Super. That's extremely helpful and valuable advice. Thank you, Thanos. Before we conclude, please tell us more about what you're doing at Cosmic Teacups.
Yeah, so I help companies push software out the door faster, happier, and with higher quality. So I work with usually small teams and go coach them of figuring out, including to using the AI tools of how to set up all these different processes and cultural aspects and make sure that software is coming out the door with these three characteristics. We usually focus on faster and with higher quality, but I think also a lot of teams nowadays are super burnt out. So I also I like to introduce the happier thing in there, because when a team is firing on all cylinders, everyone is happy seeing their work coming out the door and realized, and I think that makes a huge difference in team morale.
Super interesting. That sounds like an extremely valuable service right now, and I can see the demand for that only increasing. So that's great to hear. So Thanos, thanks again for joining us, and perhaps we can touch base again in the near future just to see how all of this is evolving and transforming this industry further.
Looking forward to that. I think that's going to be a very different conversation, even if it's in a short time from now, because the pace of change is so crazy high. Appreciate you for having me on, Thomas. It was really good chatting with you.
Thank you.
Thank you for listening. Follow Thomas on LinkedIn